I'll start the recording. So today I want to make sure you guys can start getting your ideas onto the internet so that anyone can access them, not just you. So what we're going to do is we're going to start, I know you've started a Flask app on Python Anywhere. We're going to get that Flask app into GitHub, and then we're going to get that GitHub onto your computer. When you get your idea into that GitHub repository, and then back onto Python Anywhere, and we want to make sure it's working, okay? So most of you who are Grasshopper users, you've followed the hops tutorial, right? And you have a working Flask server on your computer? Yeah? Huh? You think so? Okay. What I'm going to do is we're just going to, rather than following that tutorial, we're going to get another Flask server running on your computer, one made by Python Anywhere. Okay? So I'm going to go to pythonanywhere.com. I really like Python Anywhere. I think they're a really good service, especially the fact that you guys can make websites for free that run Python servers is like, I didn't think that would ever exist. So it's really nice to know that that's there. Pardon? I'm not sharing my screen. Thank you. Sorry. Is it sharing? I thought it was sharing. Is it sharing now? Cool. So I followed do you remember how I followed this like making a web app using Flask on Python Anywhere? Have you guys have done that, right? So you've all got like an empty skeleton of a Flask app running on Python Anywhere. Just to double check, if I go to this address, there's a there should be hello from Flask. I'm just gonna, Kerry, could you just let me know what your Python Anywhere username is? Is it? Yeah. That's a nice one. Cool. And then I'm just going to pick on Sailor, just because she said she wasn't sure. What would your username be? Sailor no dot. Peerret. Cool. This one's a little bit different. This makes me think that this isn't Flask. So let's just double check we've done everything right. I'm gonna, how do I clear this out? How do I start again? So we're gonna hit, for those of you who don't have Flask working on Python Anywhere, we're gonna hit add a new app in the web section. In here, it's gonna tell you the app's domain name, which is gonna be your username.pythonanywhere.com. We don't need to upgrade for now. Like if you ever wanna start selling this or whatever, you might want to, obviously. We just hit next. Now, these are all the various different Python web frameworks that are installed on Python Anywhere. There might be others in the world, but the two that I know are Django and Flask. Django is a really powerful web framework. I love it. There are like so many websites now run off Django. I think the YouTube video that I may have sent you sort of talks about Django and Flask, maybe. Like, I think Netflix might run off Django. And I'm pretty sure websites like Twitter run off Django or Flask or one of them. Like, they're super nice, light frameworks that are great to work with. We're going to use Flask purely because McNeil have made Python libraries that make Flask connect to Grasshopper. So in your case, you could play with Django if you want, but we'll just stick with Flask, seeing as it's simple. So we'll click Flask. Following along? Cool. We're going to pick Python 3.9, but you could pick any of them depending on what you want. And it's going to ask you where that Flask project's going to go. In this case, I'm going to put it in my usernames, my site, flaskapp.py. Okay. Next. So that should now give you a Flask server. You might need to just hit reload anytime you update it. And now I'm going to go back and check if Sailor's webpage is running Flask. Cool, it is. It's running Flask. Cool. Okay, so let me just talk about what you're seeing on this page for a moment before we move to GitHub. The code, so that what your site is running, this source code is the folder where that Flask application is saved. And that's where it's going to look for a Flask application. We can change this, and we are going to change this when we use our version of Flask from GitHub. Okay? The working directory, that's your home, and we basically don't have to worry about that too much. And the WSGI, now let me just remind myself what WSGI. The web server gateway interface is a set of instructions for your web page, the web server to deliver the information, and it looks like this. So it's a Python script. It's importing the systems function. It's defining a variable, which is the home, the project home directory. If project home doesn't exist, then it creates it, and then it imports Flask. So just make sure that the version of the server that you're running is importing Flask before it tries to run it. That's all it does. If you look at the WSGI files that might need to exist with Django or with other various types of web servers, they get a lot more complicated, okay? Don't touch this unless you know what you're doing, okay? And we're going to touch it. We are going to touch this when we come back from GitHub, okay? Because there is variables in here that we need to make sure have changed once we've run GitHub. So I know I've just said don't touch if you don't know what you're doing, but we know what we're doing, don't we? Yeah. I reckon in computational design, you know the term, like, just wing it? Like just play it by ear. It makes so much sense in computational design. It's like, I don't know what the fuck I'm doing, but I'll get there. We'll get there. Okay, so are most of you aware of what a virtual environment is? When you installed Flask or Hops or OpenPixel or whatever onto your Python, do you remember last week there was someone, I think his name was Michael? His Python, like even though he was installing... Josh. Yeah. Even though he was installing something, it wasn't, when he was running the script was like, that doesn't exist. I don't know what you're talking about. Requests, right? Install requests. What was happening was Josh's computer had multiple versions of Python installed on it, and the IDE that he was trying to run was just being pointed at the wrong version of Python, right? Now, there is actually a nice way to manage that Python provides, rather than just installing various different Pythons on your computer. Python is defined that using the term virtual environments, right? And within a virtual environment, you can start fucking around with your Python, but not breaking your main Python, right? Like if I installed, there's unfortunate, like let's say there's, I know of one. There's in Django, there's a Django plugin called Background Tasks, and there you can download Django Background Tasks by doing pip install Django Background Task or pip install Django Background Tasks, and they both are the same module when you import them, but one is good and one is bad. And if I install the wrong one, then if I install it into my main Python directory, then maybe I've fucked up my main Python directory, right? So if I do all of this stuff in a virtual environment, I can kind of go and just delete that environment. And that's not deleting or uninstalling Python, it's just deleting this sort of like make-believe virtual world. And so what Python Anywhere does is they say, we don't want you to screw around with our Python, right? The Python they provide you is theirs, and they don't want you messing with it. But what they do is they give you the opportunity to make virtual environments for you to install things that they don't have installed. So they've got Flask installed, but when we want to install things like that Rhino 3DM or Hops server, we're going to have to run a virtual environment. We're going to have to point our web server at that virtual environment. We're going to have to go into it and start installing all of the dependencies that we need. Okay? And that's basically it. The rest of this stuff's kind of superfluous. I just wanted to make sure that we eventually got to that virtual environment thing. So, if I go look at my site, the structure of this thing has a flask underscore app.py. That Flask app's got that hello from Flask, route in it. That's as simple as we need to make this, right? So we are going to recreate this Flask app, but in GitHub. Hello. Ah. Huh? Eddie. In the flesh for the first time ever. Nice to meet you. That's fine. That's cool. You've missed the most important stuff. It's where I gave everyone who turned up 5% on their next assignment. No. So, I'm hoping all of you have GitHub accounts from the previous courses. Danae doesn't. Neither probably does Sarah or Patrick, if he's there. So I need you guys, we're going to go make GitHub accounts. It's very easy to do. So jump over to github.com and make a free account. Now, how do you guys connect to GitHub? You don't? Do you use the desktop application? Do you have Git installed on your computers? You've got Git installed on your computers. Okay. Okay, so just go double check you've got Git installed. The way to do that is typing into the command prompt Git, G-I-T. Git is not recognized, so I don't have Git. So I'll go get it. I think you just type Git into the command prompt, and it should say, like, who has it worked for one of you? It works? So you can get Git from git-scm.com/download/win. Now, because this is a uni course, I'm not just going to show you how to use Git. We'll talk about what Git is and what GitHub is. GitHub is not Git. GitHub uses Git. Git is a free coding framework for storing versions and managing versions of files, right? So, when I write code and I get it to a certain stage, what Git does is it sets up a framework for me to commit that code to it's called a state. So committing that to a state, and then publishing that committed code to a central repository. Maybe it's worth me actually drawing this. Has anyone explained this to you guys? How Git works? Okay. They just said go use GitHub, and they didn't say. Huh? Push pull? Okay. No commit? Okay. It's important. I think it's really important to know because how do I make this go up? Pardon? You need to speak louder. Sorry, my ears are blocked.
What should be coming up if we do or don't have Git?
I'm about to find out. Because I don't have it.
Oh, okay.
So look, Git's actually a really interesting exercise in understanding, because from a design perspective and a building, like architecture industry, construction perspective, we really, really care about version management and change management. Like I can tell you now, Danae works in a company that's all she does is just checking whether or not things have changed. And because of the way that most code files are structured, code's usually like a text file, just with a funky little thing on, like a name on the end. So rather than .txt, it's .json or .js or .py. It's just a text file. It's not encrypted or compressed in any way. It's just a really simple text file. And so what Git does is it checks through that text file for changes and tells you how things have changed, and then asks you, hey, do you want to commit? Do you want to, approve these changes? And it does that on multiple levels. It does that within this commitment phase, and it does it also with forks. You've heard about forking? Yes, okay. Okay, so I'm going to run Git. Maybe it is worth installing Git, even though you think you might have it. I'm gonna just make sure this add a git bash profile to the Windows terminal is on, just because I feel like it might be a useful thing to have. Yes. Use Vim. Hello. Let Git decide. We want Git from the command line and also from third-party software. So this middle one, the recommended one, yes. Yes. Default. Jesus, so many fucking options. Next. Next. Done. Okay. Okay, so maybe whoever is maybe on the Teams channel, if you could turn your video on so that you can see what I'm drawing. I can't get this to go up. Yeah. Hang on. What? Yeah, sure. Yes. Why not?
Maybe check if you're illustrating.
Okay, Dingwen, I can't hear you, okay? You're going to have to send your questions via text, please. Okay, well... Huh? Yeah, next. Yes, Dingwen. Yes, just go next. Just follow the defaults. Kerry. Not Kerry, sorry.
Eddie.
Eddie.
Eddie, yeah.
Eddie, yes.
With the screen, check if you're duplicating it or not. Have you checked that?
No, I'm trying to get this to go up.
Oh.
And it's not letting me. Ah! Okay, cool. So with GitHub, there is effectively a repository, and I'm going to draw this repository as an object like that. But it's the thing is it's temporal. Okay, so this is actually now, or right? It's an object that exists now, and all of you could be accessing that as a team. You could all be working on it separately. So each of you has your own clones of that, and you'll see that word, clone. So a clone, so this might be Gabriella's and this might be Rebecca's, right? And Gabriella is going to be adding some bit to the end of the code, and Rebecca's going to be adding some bit to the beginning. And what happens is when Gabriella wants to upload that to the repository, she has to run it through a bunch of checks before it gets put up to the repository. And that's what Git does. It says, hey, you must check this. And the word for a check, so before it goes back up to there, it gets run through what is called a commit. Okay? So what you have to do is you have to say, I am willing to commit to the code that I've changed. That's why it's called commit. A commit is going to give you a report about what's changed, and you have to name it. You have to give it a name, and depending on which teams you're in, you've got to give it a description. And then when you're happy with that commit gets published back to that code. And so if I quickly, so that publish is also called a push. Okay? I didn't come up with these names. You've just got to. They've used weird names, and I actually like that because it means they don't get mixed up with other terms. So you've got a clone or a pull, a commit, and a push. Okay? Now, what happens is this changes. The instant anything is published back to that code, there's actually a new instance of the code is made, right? Now, what's happening with Rebecca? She's still working on this code, even though Gabriella has committed and published to it, right? So what ends up happening is we know this is a clone of this. We'll call this ID 0 and this one ID 1. And so when Rebecca goes to commit and publish her code, what happens is the system knows that commit is actually needing to be compared to this, and it knows what's changed from ID 0 to ID 1. And so it says, okay, well, we know that you've only worked on this part. If it can see a clash, so if the two of them have overlapped, and Rebecca actually overlaps with stuff that Gabriella committed, that's when someone has to go in and work out what to keep and what to throw away, right? And it'll give you a report and say, hey, here's a commit clash, and you've got to work it out, you've got to fix it up, you've got to go through and edit out all the stuff that needs to be edited out, or leave stuff that needs to be left in, and then once that's ready to be pushed, that gets pushed, and you end up with a new version of that, ID 2, right? It also gives you the ability to do what is called a fork. And forks are slightly larger versions of what these pulls, these clonings and commits are. So what fork does is it creates a clone of that, but on the same repository. So it's not a clone sitting on your computer, it's a clone or a fork sitting in the server. And what happens is they start to get committed, pulled, and pushed on separate tracks in parallel. And eventually, and you only do these types of things when you know that there's going to be a significant divergence between your code and the original. But let's say Rebecca is working on this fancy new thing, like super fancy new thing. So fancy, she has to rewrite half the code. She's not going to do that to the main code, right? Because if she did, then everyone sort of working off that code, they're going to get a half-finished product. So she forks it and starts, her team starts pulling, committing and publishing to that. And when they're ready, when they know that it's safe to push back in, they do what is called a pull request to merge one of these two things, into one of the other streams. So, right, this track here might end up getting pulled into this one, and this becomes the main track, and so on and so forth. And what you'll do is you'll see some major codes have significant, branching forks, and you can have forks of forks of forks. Okay? You okay? Yep. You breathe? You're able to breathe? Yeah. Cool. Does that make sense? That's making more sense, right? Cool. And so what happens is, and this is a really cool thing about GitHub, is it makes it easy for developers to give and distribute versions of their software, right? So this version of their software might work on Windows 10, but it doesn't work on Windows 11. But there are still people out there that want access to Windows 10 versions of software. Like I'm running Windows 10, right? So when I go and download the software, I'm still able to see this code at this point. And we might actually find, once we've done all these pull requests at ID 50, there's a major bug. It's so major, it's breaking. Like we're basically distributing all of our users' data across the web to hackers, and we're siphoning money off shit. Like it's just major issues. And we know that happened here, within this pull request. So we can actually say, hey, bring this old version, because the old version's still in the system, still stored in the database, bring it forward and revert back to that version, right? Every state that your code design is in is actually saved with names, dates, and the people that have been working on them, printing on them throughout this whole thing. And you can see why this is valuable from a building design perspective, right? Because now, imagine this doesn't exist in the construction industry. This structure, for some stupid reason. The software development world has come up with, I think, the best structure for change management and committing and all of this stuff. It's fantastic. It works really well. The billion dollar companies of the world, like Google and Facebook, or Meta now they're called, they all run off this type of structure of working. But engineers, architects, and building companies, they don't work with this, right? They work with PDFs and signatures. Okay? So for some of you, maybe your whole career will be trying to change the industry to be more like this. Okay? Huh?
That's Git.
This is Git. Now, what is GitHub? GitHub is just a server that saves these Git requests. And so you don't have to use GitHub. You could use your own Git server. There are other Git servers in the world other than GitHub, like Bitbucket. You might have seen some software companies using that rather than Git. So all GitHub is a free server to store this stuff. If you use it for free, this has to be accessible to everyone. So this is suddenly public, which means someone can fork your version at any stage throughout the process. They could fork that one, or this one, or this one, and they can start using your code as if it was open source. Okay? As long as they're using GitHub for free, then their version of that, their fork, is also going to be open source and people can access it. And you can do a pull request of their fork back into yours and vice versa, right? The cool thing about it is if as long as someone doesn't go and copy everything, outside of Git, this will always store the fingerprint that this originally used to be your code, right? But not like barely anyone gives a shit about that nowadays. This used to be my code. Okay, so what is the benefit of using GitHub? GitHub is this nice web framework that everyone has access to. No, I don't want to use Microsoft Edge. Why did you pop up? What's this? Go away. So GitHub's it's a web framework that everyone has access to. So your computer can upload and download pulls and pushes to that server very easily. And so rather than it just being, oh jeez, that's broken. Okay. So there's your main script that's up to date, and you're doing pulls and pushes to it. This is your computer. And then what you've also got is a Python Anywhere server, which has access to that. And all that does is pull requests. So you can do commits and pulls and update your code and whatnot. And when you're ready, you just jump on your Python Anywhere server and run a pull function. Okay? It's no different than just copying and pasting or uploading files onto that server, except you're relying on this code management system. So if you fuck this up, which you will, if you fuck your code up, you can at least say in that GitHub server, hey, revert back to an older version of the code where it worked, and then you jump back on your Python NUS server and you go pull, and guess what? You're back to where it was working, right? So this is doing a lot of thinking for you to save you in the future. Okay. Was that a necessary explanation of how it works? Okay, cool. Go learn. There's nothing to do with this assignment. Go do some more study into how Git works, because there are people out there on the internet that explain it way better than me. Maybe. Well, you can tell me that. I'm sure there are. And it's really worth paying attention to it once you start to get into your careers, okay? Because even though we're all here to draw fancy buildings, you know, it's kind of fun, the fun part of this stuff, someone out there cares about who's responsible for how that fancy building is drawn, right? Doesn't matter how fancy the building is, someone's responsible for various parts of that, and it's really hard to track in a modern world. Really, really difficult. And there's a lot of money in being able to track that stuff, okay? So just be aware of that. You know, you can end up being on top of the dog pile if you know how to track this type of data. Yeah? You'll be a boss of me if you work this stuff out. I'll be working for you, right? That's what you all want to do, right? You all want to be making more money than me, right? Yeah. Should be. Right? Whatever Andrew's doing, you want to do better. I should be the minimum for aspirations. I don't. Now, fuck you. Git. Okay. It works. So you've got a restart command. If you type git, it should run. Just double checking, is there anyone online that's asking questions? I can't see the chat, remember? No, okay. Everyone is got a GitHub account now? No, go away. Stop it. Stop it. Okay. Let's go make a repository. We're going to do this on the website. We're not going to use, we won't use the Git desktop app, but the GitHub desktop app, but I can tell you now it's really useful. It makes a lot of this a lot simpler, but let's do this the hard way. Here's the little pixel version of me without a beard. Need to update it. It's a lot more shaggy than what it used to be. It's been around for a while. We're going to make a new repository. And it's in here that we're going to name our repository. So what are you going to call your app? It's important because you can't change it. Okay? What are you going to call it? So I'm going to come up with something. What's something called? The Klein bottle. It's going to be hard to. Is that how you spell Klein bottle? It is available because I don't have any more. Name it. If you don't want to pay for GitHub, make it public. If you want to make it easy to download this onto Python Anywhere, make it public, okay? I can tell you now, none of you are working on things that are confidential. Unless you really think you've got an idea in your head that you don't want someone to steal, I'm pretty sure that someone's already had that idea. But If you do think you've got that idea, go for it. Make it private, but otherwise, let's go public. We will make, what we're going to do, see this git ignore, just go type Flask into that and see if anything pops up. No, so let's type Python. We're writing a Python code, so we would like to add a nice little Python git ignore. That's just going to save you having to upload unnecessary files in the future. We know we're writing Python, so we'll use their Python git ignore. We're going to pick a license. All of these licenses basically are if you are worried about your commercial practice. You know, you've written something for the government and you're using open source software, you want to make sure that people don't use your software to, let's say, run a scam. So you can use these licenses to make sure that you're legally covered. But MIT is quite nice, but I'm just going to keep mine on none, and we're going to hit create repository. Everyone now knows how to make a GitHub repository. I know this is doubling up on for some of you, but it's a nice refresher from last year. Look, we've got this nice empty repository called Ceph-bin client bottle. This URL is the address for my repository for Git, okay? So if I jump into my command prompt on the computer, and so the way that we're gonna navigate through this is we're gonna use this function called cd, and I think we mentioned this a few weeks ago. If we hit, you can see here right now, I'm in C Windows System 32. If I want to get out of that, I can type cd /. That will take me to the root of C. If I type dir, that will list all the directories and files where I am. So here, look, you can actually see this is exactly like if I was looking on my C drive. There's Autodesk, there's ClickShare app, there's install temp, so on and so forth. Now, I save my files, my GitHub files in my dev, in my C drive. You guys, you can put it wherever you want, okay? So you can go to your user folder and save it in your documents. The way that you can get that is if you go to users, so you go cd users, and the easy, like if you're just trying to navigate your way through, you can go dir in every folder and then eventually find where you want to go. Or you can copy in this folder structure. So I've selected the address, hit Control C, and then when I type cd, you put a quote mark and then paste, end your quote mark. The reason we're putting quotes is if by any chance you might have spaces in your folder names, then it needs those quotes to know that those folders are part of the folder name rather than the command. We hit enter, then that will take you, it'll get you to the folder that you want to work to. It's in here that we want to go back to our GitHub webpage. We're going to copy this. We're going to type git pull. So remember, pulling is the same as cloning. So we're pulling our script down onto our computer. Git pull, and then we're going to paste that web address. Oh no, not a Git repository. What? Pardon? Git pull, or do I have to do git clone? There we go, sorry. You have to go, so there's two different terms. There's clone and there's pull. Clone starts the process, and then pull is what you do after you've started the process. Cool? So this is happening outside of our Git repository. Now that I ran that, you can see client bottle is in that folder. It's a folder. So if I jump in there, there it is. There's client bottle, and all it's got in there is that git ignore. Right? if I want to do any pulls or pushes, I have to do that inside that Kleinbottle folder where the Git files exist. So I need to hit CD and go into Kleinbottle, and now in that folder I can run Git pulls, and in the case when I run Git pull, it tells me it's already up to date. Okay, now we are going to continue this in the tutorial, seeing as it's, we've only got a few minutes before the tutorial starts. Those people in real life have to actually walk, 500 meters to get to the tutorial room. So we might as well start that now. I'll talk to you guys soon when we're there, okay? We'll keep going.